Hello everyone, this is Saket Said welcoming you all to Saket Said tutorials. As lastly promised, we are back with our first video lecture on class 10th mathematics. We will begin with the first chapter of class 10th mathematics, both in CBSE as well as in NCERT. That's Euclid's division lemma. Euclid's division lemma. So here is the topic. It's Euclid's division lemma. Euclid's division lemma. Euclid's division lemma, it's actually the combination of three different terms. Firstly, it's Euclid's, then division, then lemma. Okay, Euclid's is the name of the mathematician who have given this very lemma, and what division is simply to divide something. Then lemma is actually, lemma means it's an algorithm, it's a setup, or we can say it's a process. It's a process. So this Euclid's division lemma. So if we combine these three terms, what this Euclid's division lemma mean? It's actually a process. It's actually a setup that how to divide things. How to divide things. Simple. So firstly, we will try to understand what we have studied about this Euclid's division lemma in our previous classes. Dear students, I think since from your first, second standard, you have been familiar with how to divide things. How to divide things. Say for example, if you have to divide simple 5 by 2, how can we divide this? We can divide this by like this. 2 is 4, then we will get 1. We will get 1. Firstly, we were having 5. This 5 is known as the dividend. This 5 is known as the dividend, and this 2 is the divisor. This 2 is the divisor. This 2, it is the coefficient. It is the coefficient, and this one is the remainder. This one is the remainder. So we were having dividend and divisor. What we got? We got coefficient and remainder. We got coefficient and remainder. So Euclid, what Euclid did? Euclid gave us a relation. Euclid gave us a relation between these four ingredients. These four ingredients. What four ingredients? Like we were having dividend, divisor, and we got coefficient and remainder. So these four ingredients, how are they related? That relation was given by this Euclid. Was given by Euclid. So what the relation is? Relation is actually like this. That dividend. The dividend is equal divisor into coefficient plus a remainder. Coefficient plus remainder. So now that actually the relation is this. Now it was the Euclid noted, or we can say Euclid denoted these ingredients with some specific alphabets. Like dividend was noted as small a, and divisor by small b, coefficient by small q, and remainder by small r. Now the equation becomes like this: a equals to bq plus r. A equals to bq plus r. This is the relation. This is the required relation for Euclid's division lemma. That is a equals to bq plus r, which actually means that a is the dividend. It means dividend is equal b divisor, q coefficient, and r remainder. So dividend is equal divisor into coefficient plus remainder. Okay, we can actually, you all will be familiar about that. We were whenever we divide two things, we were then if we had to check our division. How can we check our division? Say for example, like here we divide 5 by 2, then we got the coefficient q and remainder r. If we need to check this very division, how can we check this? Okay, how can we check this? We can check this only by this very thing. What? Like this dividend 5. It should be equal. If our division is correct, that means dividend 5. It should be equal divisor, that is 2, into coefficient, it's again 2 into coefficient plus remainder, remainder is 1, and 5 is equal 2 into 2, that is 4, plus 1, that means 5 is equal to 5. Hence LHS is equal to RHS. This will tell us that, how can this will tell us that our division is correct. Our division is correct. Why? Because here that dividend is equal to divisor into coefficient plus remainder. So here is the relation. Here is the relation that A equals to BQ plus R. That is, dividend is equal to divisor into coefficient plus remainder. So with this, Euclid has also defined the value of this R. The limits, actually the limits, how much the value of this R will vary. Euclid has also defined this. But Euclid had told that this value of R, it's always equal to 0, or it can be equal to 0, or always the R will be greater than 0, or will be greater than 0. That means we can never have a negative remainder. We can never have a negative integer as a remainder. So this R will be greater or equal to 0, and it will be always less than B. What B is? B is the divisor, and that means divisor will be always greater than R. Divisor will be always greater than R, and R will be always less than divisor, or either it will be equal to 0, or it will be some integer, positive integer. That means it will be greater than 0. Okay, so what are the applications of Euclid's division? This whole completes the Euclid's division lemma. So here we have to study about what are the applications. What are the applications? What application mean? Why are we use this Euclid's division lemma? By this Euclid's division lemma, we can find the HCF. We can find the HCF of two numbers. We can find the HCF of two numbers. What HCF means? HCF means H for highest, C common, and F its factor. So what HCF means? HCF is the highest common factor. Okay, we will take some books, some example from book, so that it will be more clear to you people. First question here is, use Euclid's division lemma to find the HCF of 135 and 225. 135 and 225. Let us start like this. It's question first. 135 and 225. We have to find the HCF of these two numbers, 135 and 225. How will we start? I will give you the setup, the whole setup. How you people will start the division process, then, and how you will get the common factor. Okay, we will start this. Firstly, we have to look that which number or which integer is greater than, and which is smaller. So here we have 225. 225 is greater than 135. Is it clear that 225 is greater than 135? Okay, we have to now apply the Euclid's division lemma. Let this greater digit be in box 225, and let me divide this by 135. Got it? 225 divided by 135. How can I divide this? I can divide it like this, that 135 into 1, it's 135. It's 135. 5 out of 5, it is 0. Then it's 13. 13 out, it's 12. 12 from 12, we will subtract 3. It's 90. It's 99. Now this 135, which was the divisor at the first step, it will become the dividend at the second step, and this 90, that was the remainder at the first step, it will become the divisor. So now I will divide 135 by this remainder 90. Okay, and here 91. 90 into 1, it is 90. What I will get? 90. 5, 0, it is 5. Then it's 13. Okay, 9, it is 45. It's 4. It's 45. Now this remainder 45 will act as divisor, and this 90, which was the divisor, it will act as dividend. Now it's 90 here. Now what I have to do? I have to divide 90 by 45. Now 45 into 2, that is 90, and I got 0 as reminder. I have to carry on this practice. I have to carry on this process, this practice, this setup, this algorithm, this lemma, till I will get the remainder as 0. I will get the remainder as 0. And since at any step where I will get the remainder 0, the divisor at that very step, that will be the HCF of the two numbers. So here I can say that HCF of 135 and 225 is equal to 45. Is equal to 45. Why? Because when I carried that Euclid's division lemma, and at the final step where I got the 0, the divisor at that very step was 45. So hence the divisor is 45, and hence the HCF of 135 and 225 is 45. But this is the division, or I can say this is the rough work. This is the rough work. I have to write this very setup. I have to write this very setup in this relation. A equals to BQ plus R. Firstly, first step. A, for A, what A is? A is the dividend. What is the dividend here? It's 225. 225 is equal. B is equal to B, divisor. What is divisor? It's 135 into coefficient. What is coefficient? Into 1 plus remainder. What is remainder? It's plus 90. This completes the first step. 135 into 1 plus 90. Now second step. What? A. What is A? A is a dividend. So here 135 is equal B, divisor. What is divisor? It's 90 into coefficient. What is coefficient? Coefficient is 1 plus remainder. What is remainder? Remainder is 45. This is the second step. Now third step. In third step, where I got the remainder 0. In third step, dividend A, dividend. What dividend is? Dividend is 90. So 90 is equal divisor is 45 into coefficient is 2 plus remainder is 0. Now here I got the remainder 0. So therefore HCF is equal. Final step, I got the remainder 0. So here the divisor was 45. So the HCF is 45. This is the Euclid's division lemma. This is how can we find the HCF of two numbers by using Euclid's division lemma. Got it? Now there are 3-4 questions where you have to apply the same method. I hope you people will do this same. Okay, you people will try this, and if any problem persists, do comment down so that I can better assist you. Okay.